Hello, geometry students. Mr. Zacek back and better than ever. We're here in Unit 12, Lesson 2. We're going to be looking at volume and surface area of prisms and cylinders. So, just reading here, a prism is a three-dimensional solid figure with two parallel faces called bases that are congruent polygons and lateral faces which are rectangles in a right prism and are parallelograms in an oblique prism. So polygons are named by the shape of their base. Whoops. So we'll keep that in mind as we go through here and look at these things, that polygons are named by the shape of their base. So and they're congruent and parallel. So you see here we have a rectangular prism. So the base would be where we see the base here, and then the faces are the other side. A triangular prism has a triangular base, and then it has three rectangular lateral faces. And then a square prism, this is oblique. Oblique means where it's kind of like tilted out to the side. If you're doing like an ab workout and you tilt to the side, that works your obliques. And so the thing to keep in mind with oblique ones is that the height is often, you got to measure the height from down here, because height is always perpendicular to the base. So we see a couple others: a pentagonal prism, a hexagonal prism, an octagonal prism. We're just referring to the base. And then a cube is a square prism whose length, width, and height all have the same measure. So cubes are common, and then rectangular ones and cubes are going to be our most common ones that we'll deal with. So as we were talking about before, we have a right prism versus an oblique prism, and I'm going to go right to the picture here. In a right rectangular prism, this height is perpendicular right here, what you see in this picture. Whereas in oblique prism, you got to do the height on the outside, because the height always has to be perpendicular. The other thing to note is that with the rectangular prism, the right one, the cross section would be whatever the base is. And over here, that you still have a cross section, but that's where it can be a parallelogram. So right versus oblique. A regular prism, we've talked about this word throughout the course of many previous lessons, but basically everything is congruent here. As a regular prism has a regular polygon as its base, and so all of the lateral faces are congruent. So your lateral faces are the sides. Like if you were to, this stuff here is the lateral faces. So in prisms, let's just identify some properties. The bases are parallel and congruent. The lateral faces are rectangles if it's right, or parallelograms if it's oblique. The lateral edges are parallel and congruent, and we name them by the shape of their base. And all cross sections parallel to the bases are congruent to the bases. So basically what you can think of with a prism is it's like the base stacked on top of each other. One of the examples that I use is like sticky notes. Like a packet of sticky notes is like a cube or a rectangular prism that you have all stacked up on top of each other. Okay, so when we're looking at volume and surface area, the volume is the total number of cubic units enclosed by a three-dimensional solid. And so the surface area is the total number of square units of all three-dimensional surfaces. So you're going to see this formula. This is on your formula sheet. The biggest thing people need to remember with this is that the capital B is the area of the base. Okay, so a lot of times people confuse that for just the base. It might be a length, but capital B is the area of the base. So essentially what's happening, here's how I think about this. You've got this piece right here, and it's a rectangle, And what we're doing is we're figuring out how many rectangles are stacked on top of each other. That's the base times height idea. And so you could read that. It gives a little more specifics into that example. Now the surface area is, here this is called a net diagram. When you take this and we draw it, we just sort of flatten it out. It's the sum of all these areas all added together. So when we are figuring out the surface area, we find the sum of the area of the base, two bases, and then we find all of the lateral faces, and we add all of those things up. So we know how to find the area of a triangle, we know how to find the area of a rectangle, so we can find all of those individual areas and add them together. Okay, now a cylinder is similar, except the difference in a cylinder is that the bases are circles, and here's one, the lateral area is a rectangle. So you see, if you take a soda can, the side of this is actually a rectangle. And in the same way with prisms, we have right and we have oblique cylinders. So you can look at those pictures and see the difference. Again, the oblique is one where it's tilted out to this. And so properties of a circular cylinder, the bases are parallel and congruent, they're circles, and all of the cross sections parallel are congruent. I like to think of this as like a CD tower stacked on top of itself. It's just a bunch of CDs that you have with it. So same formula here for the volume of the cylinder, except for now, again, B, key thing here, B is the area of the base, but since the base is a circle, right, for the area of a circle, what's that formula? Pi r squared. So that's what you're substituting in there for that B. And again, you can think of it like a whole bunch of CDs stacked on top of each other. So when you're finding the surface area for this, all right, it's the area of the bases plus the lateral area. The thing with the lateral area is that this distance right here is d pi, because the circumference is what wraps all the way around that circle. So that's how you can find that length up there at the top of this. Okay, so this principle, there's a principle, and this is a specific standard in our curriculum this year, so that means it just sort of likes to get ask you about it and things, is that if two solids have the same height and the same cross-sectional area at every level, then they have the same volume. So we look at this example. The following cylinder was sliced into 7 sections. The sections were then placed on a slant. Since the volume of each individual section did not change, the volume of the stack is the same. So when you have, whether it's a right cylinder or it's an oblique cylinder, it's still the same volume. So here's another example. This is the kind of the sticky note thing. The stacks of paper contain the same number of sheets. The stacks have the same height. The area of each cross section parallel to the base is the area of one sheet of paper. Therefore, the stacks have the same volume. Okay, and so this is Cavalieri's principle. And so in this example, the area of each shaded cross section below is 6 centimeters squared. Since the prisms have the same height, their volumes are the same by Cavalieri's. So in this Cavalieri's thing, what they need to do, here are the two conditions. Number one is they need to have the same height, and number two, they need to have the same area of the base, or bases, plural. So if those two conditions are met, then they have the same, they'll have the same volume, okay? Okay, so we covered a lot of ground there, and it might be worth reading some of those things over in a little more detail. But what we're going to get into is some examples here now. It says find the volume of this. So the volume formula is the area of the base times the height. Now when you have a rectangular prism like this, we have to define what are we going to call our base. So it doesn't, there's actually two ways of doing this. I'm going to call this my base, okay? So this is going to be B. I'm just going to draw it separately. This is 12 by 8. So capital B, which is length times width, is going to be 12 times 8, which is going to be 96. That's the area of the base. And then this, if that's my base, this would be the height here. So our formula for the volume is going to be 96 times 4. Okay, so 96 times 4. So what is 96 times 4 is 384. So the volume will be 384 yards cubed. Now again, common error point is with this B, people just put in like they do 12 times 8 or something like that. So here, cylinder volume equals still area of the base times the height. Now what's our base in this case? Well, our base is a circle. It's got a diameter of 16. So if the diameter is 16, that means the radius is 8. And B is going to be pi times the radius squared. So that would be pi times 8 squared, which would be 64 pi. So that's our area of our base, and then our height is 5. So the volume would be 64 pi times 5. And we've been asked to leave this in terms of pi, so we're just going to multiply 64 times 5, which is 320 pi feet cubed if we wanted to put units on it. Okay? So again, you see the difference between how those formulas are used. They both have capital B, but one has a rectangular base, one has a circular base. Okay, so now we have a couple of little variations of this. Okay, so in number 1 here, a solid metal prism has a rectangular base with sides of 4 inches and 6 inches and a height of 4 inches. A hole in the shape of a cylinder with a radius of 1 inch is drilled through the entire length of the rectangular prism. What is the volume of the remaining solid to the nearest cubic inch? Okay, so this is basically being drilled out of it, this inner cylinder. So really what we need is, we need the volume of this rectangular prism minus the volume of the cylinder. So when we think about that, the volume of a rectangular prism is going to be the area of the base times the height, and the volume of the cylinder is going to be the area of the base times the height. But for the cylinder, we know that the area of the base is pi r squared h. So we got to adjust that slightly. So for your rectangular prism, pick your base. I'm going to do the 4 by 6 as my base. So for this piece of it, the area of the base would be 4 times 6, and then the height there would be 4. Now for our cylinder, we have a radius of 1, so that's going to be pi times 1 squared. And then if this is the base, this cylinder has a height of 6. Okay, so now we're going to multiply this together. We get 4 times 6 is 24, times 4 would be 96, minus 6 pi. And so this says leave it to the nearest cubic inch. So we'll go ahead and do this. 96 minus 6 pi thing is down here, pi. And 77 0.1. So to the nearest cubic inch would be 77 cubic inches. All right. So again, just looking at a volume of a cylinder and a volume of a prism. A fish tank in the shape of a rectangular prism has dimensions of 14, 16, and 10 inches. The tank contains 1,680 cubic inches of water. What percent of the fish tank is empty? So as you're looking at this, a tank, which is in this rectangular prism, if you want to draw these, sometimes you can just draw two rectangles and offset them and connect them here. So we've got dimensions that are 14 by 16 by 10. Okay, so this is not drawn to scale. So pick your base, what you want the base to be for this. And in that case, if this is our base, the area of that would be length times width. So the area would be 14 times 16. So what's 14 times 16? 224. So the area of the base would be 224. So volume, which is the area of the base times the height, would be 224 times 10. So the volume would be 2,240 cubic inches. Now the tank contains 1680. What is the percent? What percent of the tank is empty? So let's first figure out how much is not in there. So if we subtract 1680 from that value, so 2,240 minus 1680 is 560. So that means we've got 560 cubic inches that's not being used. So 560 divided by 2,240. Okay, so 560 divided by 2,240, and 1/4, which would be 0.25. So that means that 25%, we multiply that by 100, 25% of the tank is not being used. So you decide to finish filling the tank with a 5-inch tall cylindrical cup that has 4-inch diameter. So you got a cup, it's a cylinder, okay? It has a diameter down here of 4 inches and it's 5 inches tall. How many cups would you need to without going over? So we need the volume of this. So the volume is the area of the base times the height, but again, the area of the base is pi r squared h. So the diameter is 4, therefore the radius is going to be 2. So it'd be pi times 2 squared times 5. All right, so let's figure that out. Let's put that in. So 5 times 4, 2 squared is 4, times 20, 2 squared, times 5 times pi is 62.8319. So 62.8319. And without going over, so let's see, we've got what, 560? So 560 divided by 62.8319 is 8.9. So if we want to 9, we would overflow. So we did 560, that was how much remained, divided by 62.8319. That was approximately 8.9. So we could put in 8 cups without going over on that. Okay, what else do we have left here in this? So there's some other types of examples that we have on here, and maybe what I'll do is just to split this up a little bit, I'll finish those, but I think you have an idea of what we have going on here. Let's actually finish up this. We'll just do this one triangular one. Volume of the prism, shown in the accompanying figure is that what is the length of the dimension labeled. So in this case, again, the volume is the area of the base times the height. So the area of the base here is 1/2 small b times h. So we know that this volume is 12.5. 1/2 2 times 2.5. See, that's the area of the triangle, and then times x. So this would be 12.5. 1/2 of 2 is 1. 1 times 2.5 is 2.5x. So then we would just divide this by 2.5. So 12.5 divided by 2.5 is 5. Okay, so 5 would be x. So I think we've got what we need here. You know, we've seen a triangle, rectangular, cylinder, some of the little variations that we have, and we'll get some more practice on this in our assignment. Alrighty, these formulas are on the reference sheet, but they're with a capital B. Keep in mind that is the area of the base. So I'll see you back here soon.